limit definition of derivative. We have a function f of x equals to x squared. When x is equals to 4, you plug in 4 to x. 4 squared is equals to 16. So 4 comma 16 is a point on the curve. You can call this a position, or the x squared, you can call this a displacement function. So for the displacement function, you give me an x value, I plug it in, I give you a y value. So this x comma y is a point on the curve. So whenever you give me an x value, I can give you a position. So when x is equals to this, y is equals to that, so that is a position. In the previous lesson, I talked about limit definition of derivative at a point, at a specific point. So at a specific point means at that point, you have to tell me what the slope is. So we have a parabola. When x is equals to 4, you have to tell me what the slope of the parabola is at this point. How about this? Can you find one function to describe the slope of the given function at any point? The answer is yes. That's what we are going to discuss in this video. So f prime of x, we are not plugging in a specific number. We just use x. So f prime of x is the derivative of f at x. So that derivative has multiple names. You can call that the rate of change. Sometimes I use ROC for short, rate of change of f at x. Or in application problem in physics, you can call that velocity. So the velocity of the displacement function or the position function f at x. Or in general, we call that the slope of f at x. I am looking for the slope of a curve at any x value. Okay. So again, we are trying to find one function to describe the slope at any x value. So the limit definition of derivative is limit as h goes to 0. The top we have f of x plus h minus the function itself divided by h. This is use one function f prime to describe the slope of f at any x value. Some textbook use a different name. They call this a difference of quotient. But most of the textbook just call this limit definition of derivative. Okay, x squared sounds too easy. So this one I use a more complicated function, x to the 4th plus 2. I want you to find f prime of x. Again, whatever that equals to, f prime of x equals to something that is one function to describe the slope of x to the 4th plus 2 at any x value. All right, so let's start. So the first step that I would like to do is I always start with the limit definition of derivative. So let me match the color. I'm going to change that to purple. So we have f of x plus h minus f of x divided by h, and then I will plug in x plus h to the given function. So always start with an equal and limit. So we have x plus h raised to the 4th power plus 2. So that is your x plus h. And then you minus the function itself. The function itself is x to the 4th plus 2. And then you divide by h. Alright, and then the next step is you will have to fully open the top. So how do you open up a 4th degree? So to open up a 4th degree, you can use any method you like, but the method that I introduce a lot is called Pascal Triangle. So I will just write down Pascal Triangle. So Pascal Triangle start with a 1, right? It starts with a 1 on top, and then you have a 1 and 1. I'm going to leave some space on the right. So starts 1, and then the next line start with a 1, ends with a 1, and then here comes with that technique. You start at a 1, and then 1 plus 1 equals to 2, and then ends with a 1. 1 plus 1 equals to 2. You start with a 1, 1 plus 2, 2 plus 1, you end with a 1. And then start with a 1, 1 plus 3, 3 plus 3, 3 plus 1, end with a 1. And then the next line start with a 1, 1 plus 4, 4 plus 6, 6 plus 4, 4 plus 1, and then you end with a 1. And then you can keep on going. Okay, so we do not count the top, and then this line is the first line, and then we have the second line, the third line, the 4th line, and the 5th line. Okay, which one are we using? So since this is a fourth degree, So since that is a fourth degree, then we will follow the fourth line. So the 1, 4, 6, 4, 1. The way we use that is we write this down for the coefficient. So 1, 4, 6, 4, 1. And then since this is a x plus h, the sign pattern is all plus. Is all plus. And then h, we raise that to the fourth power, right? So that is x to the fourth, x to the third, x squared, x to the first, and x to the 0, which is 1. And then the h, we have h to the fourth, h to the third, h squared, and then an h. Okay, and then what if you have a x minus 4? Just a what if? So what if you have a x minus 4 to the fourth degree? What if you change the x minus h? If the sign is a minus, then the plus and minus sequence alternates. So you have to use a plus, minus, and a plus. The sign alternates. All right. So back to the business. So now let's put that. Let's fully open that up. So we have a limit as h goes to 0. So we have a x to the fourth plus 4x to the third h plus 6x squared h squared, and then plus 4x h to the third, and then plus h to the fourth. So that opens up the fourth power. And then you add 2 minus x to the fourth, and then minus 2. You distribute the minus sign. And then you have the whole thing divided by h. Now, the next step, all the coefficients must be cancelled. If they cannot be cancelled, then you make a mistake. Where are the coefficients? We have a 2, we have a minus 2. That's it. And then what else? How about the x? The x, we have a x to the fourth and a minus x to the fourth. Cancel, right? And then check the rest. Every single term has an h attached to it, and then you factor out an h. So you have a limit as h goes to 0. You have to factor out 1h, and then you have 4x to the third plus 6x squared h, and then plus 4x h squared plus h to the third, and then you divide it by h. So our biggest enemy is the h in the denominator because h goes to 0, but now we get rid of it, then the job is done. So simply plug in h goes to 0, so that means all the h terms becomes a 0, and then you have a 4x to the third. This is the answer of the limit. What does this mean? You did the math, you did it right. What does that mean? This is f prime of x equals to 4x to the third. The meaning of this answer is the slope of f at any x value. I just use one function, 4x to the third, to describe the slope of the given function at any x value. Now, if you want to find a specific slope, so let's say I have a function, right? Our function is x to the fourth plus 2. So let's say I want to find a point. So you have to give me an x value. So let's say just for example, how about x equals to 1? So let's say x equals to 1. Just for example, you will have f of 1. So that is 1 to the fourth plus 2 equals to 3. So our point is when x is equals to 1, y is equals to 3, right? What is the slope? 1, 3 is a position. How about the slope at this point? So when x is equals to 1, f prime of 1, you have to know what you are getting. If you are looking for a point on the curve, you ask the f of x to do the job for you. If you are finding a slope, then you are asking the f prime to do the job for you. So since I am looking for slope, I have to plug it into f prime. So that is 4 times 1 to the third equals to 4. And then this is the slope of f, function f, at 1, 3. So now we have a slope and then we have a point. What is the equation of the tangent line? So slope is equals to 4, and then the point is 1, 3. To find the equation of the tangent line, you have to use a point slope form. Y minus y1 equals to m times x minus x1. This is called point slope form of a straight line. So y minus 3 equals to 4 and then x minus 1, right? So you have y equals to 4x minus 4 and then you add 3 to it. So y equals to 4x minus 1. So y equals to 4x minus 1. What is this? This is equation of the tangent line to the given function at that specific point, 1, 3. So we have a curve. The curve just looks like a parabola. So the given function, the x to the 4 plus 2, just looks like a parabola that opens up like this, just like a parabola. And then when x is equals to 1, y equals to 3, we have a point right over here. I am looking for the slope of the parabola. At this point, the slope is equals to what? The slope is equals to 4. And then we build a tangent line. The tangent line looks like that. This is 4x minus 1. This is the tangent line. The slope of the tangent line is equals to 4. We are trying to use the slope of the tangent line to estimate the slope of the parabola. So since they are touching each other at this point, the slope of the parabola is also equal to 4. So that's it for this video. So one big summary for this video is you are finding one function to describe the slope of the given function at any point. So you are not plugging in any value to your limit. You will just use x for general. So at the end of the day, your function has an x attached to it, right? Your function has an x. It has an x. It's not a specific, a real number. Okay, and then this is one function to describe the slope of the given function at any x value. All right, so that's it for this video. If you like it, give me a like, share the video, subscribe to my channel if you're on your way out. I will see you all in the next one. Signing out.